the chain rule for 2 independent variables and 3 intermediate variables. Suppose you have a function in 3 free variables. X is a function of R and S. Y is a function of R and S. Z is also a function of 2 variables R and S. If all 4 functions are differentiable, then W has partial derivatives with respect to R and S given by the partial derivative of W with respect to R is the partial derivative of W with respect to X times the partial derivative of X with respect to R plus partial derivative of W with respect to Y times partial derivative of Y with respect to R plus partial derivative of W with respect to Z times partial derivative of Z with respect to R. Now, let's go to the second free variable S. Partial derivative of W with respect to S is partial derivative of W with respect to X times partial derivative of X with respect to S plus partial derivative of W with respect to Y times partial derivative of the Y with respect to S plus partial derivative of W with respect to the last variable it has, which is Z, times partial derivative of Z with respect to S. This question says express the partial derivative of W with respect to R and also partial derivative of W with respect to S in terms of R and S if W is X plus 2Y plus Z squared, X is R over S, Y is R squared plus ln of S, and Z is 2R. Let us begin. We're following the formula. The first formula is the partial derivative of W with respect to R, which is going to be 1 times 1 over S. Why 1? Because we are taking the derivative of X plus 2Y plus Z squared with respect to X. So Y and Z are fixed. The derivative of X with respect to X is 1. Then the derivative of X with respect to R is just 1 over S. Plus, let us take the partial derivative of W with respect to Y. Again, when you're taking the partial derivative with respect to Y, X and Z act like a constant. So the derivative of X is 0. The derivative of 2Y is just 2. The derivative of Z squared is just 0. And then multiplied by the partial derivative of Y with respect to R, which is going to be just 2R plus 0, because ln of S doesn't have any R in it. And finally, with the same logic, the partial derivative of W with respect to Z is 2Z. Partial derivative of Z with respect to R is just 2. So we can simplify that as 1 over S plus 4R plus 4Z. Z is equal to 2R, so we can simplify this further to 1 over S plus 12R. Now let us move on to the second formula. Partial derivative of W with respect to S. We're just following the same format, the same logic. The partial derivative of W with respect to X is just 1, but partial derivative of X with respect to S is negative R over S. Following the quotient rule, plus, so here you have 1, then you have negative R over S squared, plus partial derivative of W with respect to Y, which is just 2, times the partial derivative of Y with respect to S, which is the derivative of ln of S, or 1 over S, assuming S is positive, plus the partial derivative of W with respect to Z, which is 2Z, but the partial derivative of Z with respect to S is 0, because Z has no S in it. So the partial derivative of Z with respect to s becomes 0. That's how you end up with this 0 here. So you can get rid of the last term. You get negative r over s squared plus 2s. So this is the partial derivative of w with respect to s.